From earlier section, the last video was dealing with the resistor circuit. Similarly, this class also will be dealing with resistive circuits only. Right, so earlier we did some of the basic resistive circuits. Today we'll start with some basic resistive circuits, and as the video progresses, we'll do a little bit complicated circuits. For 1 hour, or I have decided to use 1 hour for circuit analysis. Right, now let's move on with the first resistive circuit. Let's break up one first one, basic one. Suppose this is your A, and there is a resistor like this, then we got a resistor. It's an oval shape, okay? Let's see how many of you guys are able to solve the circuit, guys. Let's make this a 6, 12, this is 4, or our ohm, okay? This is 1 ohm, this is 2 ohm. While doing, once you got the circuit, you guys can pause the video and try to solve it by yourself. Right? I think this is high time you guys can solve it by yourself. This much time only is required. Okay. See, it's an all less potential method which I have taught you guys. That is same nodes. When there is no element in between, the same, this A point A is same carry out to this entire wire, and this point is also becoming A. Right, if this point is B, then this entire points or in their section is B, so this point is also B. Now from B to this section there is no devices in between, so this point is also B. Now this point A, from here there is no intermediate devices, so this point is also A. Right, so in between A and B, this entire resistor is coming up. So if I draw an equivalent circuit for it, will be point A and point B. Between them, let's move on from here. A to B, 2 ohm resistor, 2 ohm, right? Right, now A to B, 6 ohm resistor, 6 ohm. Now B to A, 12 ohm. Let's make it as like this, 12 ohm. Now A to B 4 ohm, to B 4 ohm. Now A to B 1 ohm, A to B 1 ohm. That means became a simple circuit. This 4 elements or 4 resistors are in parallel for this, or the circuit is just like this. So once you don't understand by looking at a circuit which looks like an oval, you made it into a simple circuit which is 4 resistors in parallel. So what is equivalent resistance here? How would you calculate? This 1 by R equivalent is equal to 1 by R1, that is 12, plus 1 by R2, that is 2, that is 1 by 6, plus 1 by 4, plus 1 by 1. Right, so you will take LCM as 12, so it becomes 1 plus 6 plus 2 plus 3 plus 12 whole divided by 12. Don't ask me how the LCM is taken. You guys are 12th class student. So this is 8 plus 9, then 12, 12 plus 12, that is 2 into 12, that is twice, right? Divided by 12, so the answer is 2 ohm. So the equivalent resistance is 2 ohm. Simple? Right. Now let's move on to the second simpler resistive circuit. Right. How would you draw it? Let's make another circular form. Okay, this is my second circuit. Right. I'm going to draw it in the light form. Then we have to draw something in between. So I'll make it as light. This is one resistance. Shit. Sorry, I cursed. I cast my, sorry. 2 R, and this is 2 R, and this is also 2 R. Okay, right. Then they are asked what is equivalent resistance here. There is a resistance here, okay. How would you calculate? Same method here. Again, I am asking you guys to pause the video while solving the circuit. Try to do it by yourself. If you are not getting it, or to confirm whether the answer is correct, you guys can cross over with the video. Now let's make this point as A. If this point is A, then this point is also A, then this point is also A, and then this point is also A. Let's take this point as B. Now you got the answer now itself. So there are 2 points here. Between A and B there is an R ohm resistor. Now between B and A there is another R ohm resistor. Now again between A and B there is 2 R ohm resistor, 2R, and there is another 2R ohm between A and B. So you got an equivalent resistance like this. How would you solve it? 2R and 2R are in parallel, so it will be what? Don't go by this 1 by 2R plus 1 by 2R. Don't go by this one. When you are having equal resistance in parallel, and there are 2 guys, right? So 2R by 2, this is R, this will be R by 2. I hope you understand. When there are n number of resistors, they are in parallel, the equivalent resistance is R by n. So there is 2R and 2R. 2 resistors are in parallel. So it is 2R by 2, that is R. And this is to R resistance, or there is resistance R and then another resistance R, they are in parallel, and 2 resistors, so it will be R by 2. That is, if I draw, it will be like this. These 2 resistors cause a resistance R by 2, and these 2 resistors cause a resistance R, right? And they are again in parallel. So now you can use R1 into R2, that is R by 2 into R, divided by R1 plus R2, that is R by 2 plus R, that is a R equivalent. That will be R squared by 2 divided by R plus 2R. So it will be 3R by 2. So 2 cancels out and R cancels out. So the answer will be R by 3. Clear? Now let's move on to a complicated stuff, guys. That is infinite method. We did the same in the case of what? Capacitor. So this section should be easy for you guys if you understood that capacitors part. Suppose the resistor circuit is like this. Let's make a large one. So this is from infinity. And this goes on to infinity. So, and these are all R. I'm showing just an example. This can be of any values. This R and R, etc. can be different values. Now, whenever you're having this type of circuit, what would you do? You will find the pattern or where the section which is repeating, or you will say finding the repeating unit. Which unit is repeating? This R and R, this R and R, and this R and R. The next section here will be R, the next section R, like this. So, you can say this R unit is repeated. So, I am going to take this R combination as R equivalent, or I can say yes. See, this is an infinite pattern. Even if I remove one section from it, it is not going to make much difference because it's something which is going to move on through infinity. So what would you do? You'll assume that suppose the circuit's entire equivalent resistance is X. Right? So let's take this entire resistance equivalent value is X. Right? So or I can say, right, so this is R, this is R, right? So this much section center or R equivalent is X, means if you lose or if you remove these 2 guys also, this entire section's equivalent resistance will be also X. So here I will replace this entire section, this much section with the resistance value X. This much clear? Now we are going to find the answer, or we are going to find the equivalent value of this circuit. That is, from here I can write this R and X are in parallel, so R into X divided by R plus X, right? Replace these 2 resistance with this value, that is Rx by R plus X. So it will be what? R, this is Rx divided by R plus X, right? That is the equivalent resistance X. So X is equal to, these 2 guys are in series, so just try to add. So X is equal to R plus Rx divided by R plus X, right? Now let's move on, solve this equation. So this becomes X is equal to R squared plus Rx whole divided by R plus X. That is equal to xr or rx plus x squared is equal to r squared plus 2rx. Right, I can remove one rs here. Right, so it will be x squared minus r squared minus rx is equal to 0. Right, so you got a quadratic equation, right? A squared minus b squared minus bac, like that, or x squared. You can write r squared in that end if you want. Right, I can write it as x squared minus rx minus r squared is equal to x. This is a form, right? I just rearrange. So x squared, right? So it is, now what is the solution for a quadratic equation? X is equal to minus b plus or minus root of b squared minus 4ac by 2a. This is the solution of any quadratic equation. So here in x, b and whatever it is written, your eyes can find. Right? Right, now let's put some values accordingly. So what is minus b here? To minus or minus r will be r plus or minus root of, what is b square here? R squared minus 4, right, into ac, right? A is 1, c is minus r squared, right, divided by 2a. A is 1. This much is value is correct. So when you solve, you will get r plus or minus root of 5r squared. So I will write it as root 5r divided by 2. So minus values can never be resistance value. So the answer will be r 1 plus root 5 whole divided by 2. Right, this much is clear. Right, let's move on to the another example, guys. That is, next topic is Wheaton's bridge. Right, I think you guys have clarified the section, that is resistive circuits. Infinity is easy, right? So you got the value of x, that is the equivalent value of resistance. Now let's move on with the next section, which is Wheaton's bridge. We did the same with the capacitance also. Right, now let's make a resistive circuit like this. 3 ohm, this is 2 ohm, 1 ohm, and there is a 4 ohm resistance here. It's a 2 ohm resistance here. This is B, this is A. How many of you guys can solve it by yourself? You can check by pausing the video and try to do it by yourself. It's very easy. How would you, I didn't write the value here, right? How can you say 2 by 1, 2 is to 1, 4 by 2, 2 is to 1. Both of them are having same ratio, means I will say this Wheaton's bridge is what? I will say this Wheaton's bridge is balanced. Right, balanced means these 2 points, suppose this point P and this point Q is having same potential. Same potential means no flow of current, because flow of current only happens from higher potential to lower potential. So balanced Wheaton's bridge condition, if it is satisfied, indicates this point P and this point Q are having same potential. If they are having same potential, no flow of current means I can remove this 3 ohm resistance, so there will not be any resistance there. I'm going to use a whitener over there. Right, so there is no resistance over there. So now you guys can use, or you can solve this circuit very easily. What 2 and 4 ohm are in series, so this will be 6 ohm in parallel with what 1 plus 2, that is 3 ohm. So 6 into 3 divided by 6 plus 3 is 9, 3, the equivalent resistance is 2 ohm. It's a very easy circuit. This much is clear, I believe. Right, now we'll move on with the second part. When the same scenario, it will not be asked as it is. Some of the times it will be twisted. And similarly, this balanced section, or why this potential at P and why the potential Q or AC itself, this much portions will be taught to you guys in this chapter itself. But in the later on section, there you have to understand Kirchhoff's voltage law, Kirchhoff's current law, etc. Now while solving a resistive circuit, just understand that when the Wheaton's bridge is balanced, you have to undergo, or you have to do the same scenario. Now guys, I have done the unbalanced condition also in capacitance, so you guys can also solve that part. Right, believe so. Let's see how many of you guys can solve the section with the unbalanced resistance bridge. Let's see.